It's recording. All right. So, hey, I need a new note. That humming, though, it's one of those like things that'll drive you batty. Do you guys have a lot of due date or deadlines or something going on? Is that why no one's here?
I think a lot of people jumped at the opportunity to drop courses. They found that they could defer them.
Oh,
I think we were told
really?
yesterday, like if you only want to hold on to some courses and drop.
Oh, then you're allowed to just kind of put it off. I think, yeah, today's the ad drop date. We'll see. We'll see. Well, that's good. Yeah, because I know they bumped it, but are you able to do anything yet? Feels like they kind of bumped it thinking it would be ready to go, and then I'm not sure it is. And
If you have to go in person or something instead.
tricky.
I don't even think our outlet is working.
Yeah, I don't know what is working.
We are not, I'm not getting emails. And then emails to email.
Oh, really?
And the professor.
Yeah. Yeah, because usually I have access to your preferred email, like your personal email through my Okanagan, but I can't get into my Okanagan. So I only have your kind of Moodle, your my Okanagan email address, which is probably not set up to forward to your personal email, which is usually one of the first things you would do is set up, you would have it forward to your Gmail or whatever, right? Or if you're old like me, your Hotmail. I know. It's embarrassing, but it's gonna be cool one day, I think, right? Oh, you've got a Hotmail account? Yeah, I do. Anyways, where was I? Okay, so Kate came by, did her intro, so that's great. I'm so glad because usually it's us playing phone tag and not on the phone, but just by email. Trying to sort out when to come, and then so I'm glad we got that done. Okay, so just to pick up from last day, I'm gonna grab this because the very last thing I want to talk about is, so from continuing from last day. Just comparing box plots with histograms, right? Oh, and then what we're gonna do today is we're gonna start categorical data and see how far we get. And then we will talk more about categorical data on Thursday, probably. We'll see how far we get. But whatever we do on Thursday, I'm not gonna have on the quiz, right? So it's up to today, we'll be on the quiz. We'll talk more about it, hopefully fill in some gaps on Thursday. But in general, I'm not going to quiz you on anything from the Thursday because the quiz is on Friday, quiz 1. Maybe that's what I should write here. Bump all this down. Quiz number 1 is on Friday in class. Okay.
Sorry, Emily.
Oh, hello. Yes. Oh, sorry. That was scary. Yeah.
Sorry.
No worries.
I was just wondering, like how many questions the quiz, the format might be.
So what I'm thinking is I'll give you guys a practice quiz on Thursday, and then you'll have a good idea. From where Yeah, because if I say 2 questions, that doesn't mean anything if there's like 14 parts. So I want you to have a good idea of what the quiz, and because we got off to such a rocky start, I am gonna give you a practice quiz for this one. And then, and also because we haven't had much in the way of assignments because it's all shut down. And so I'll give you a practice quiz on Thursday, and that'll give you a good idea of what to expect. Right.
Perfect, thank you. Perfect, thank you.
Awesome. On material up to the end of today. Oh, today. Yeah. So that's just the end of today, wherever we get to. So that's why I don't have a firm answer, because I don't know how far we're gonna get to today. Okay, so any questions about the quiz before we move on?
It'll be done online, right?
No, we have to do it in class. So last term, if you've talked to your friends who took it last term, then I was doing them online, but in class. One, we don't have access to that system right now, but also I was slapped on the wrist for doing that. So I can't assume that you all have laptops, I guess. So it's just going to be a written test, a written quiz.
Sorry.
Yeah. Quiz, just a quiz. It's breezy.
It's gonna be MCQ or?
It'll be a little, maybe a couple of multiple choice. I'm still kind of deciding on what I want it to look like. I have a couple of questions up my sleeve, but how I'll do it. I might do a couple of multiple choice, but some main things, right? You'll have to give me a 5-number summary. Tell me if there are any outliers, right? That's one question. How do we find outliers? 1.5 IQR rule from last week, right? And so that's kind of the quiz material from last week. What did we do before then? I give you a data set. You have to tell me if things are numerical or categorical, right? That kind of fun stuff.
There won't be calculations to find the standard deviation.
No, not finding the standard deviation. Maybe the mean. But you all know how to do that, so why would I quiz it, right? And so anyway, but sometimes I do put those easy marks questions on there just to boost morale, right? Get your grade up a little bit. Okay, and we're just getting to know each other, right? So you especially are getting to know me and my quiz style, right? And so even though I think I'm making quiz 1 quite easy and approachable, right? It's your first time seeing something from me, so I'm also taking that into account, right? So it should be good for everyone, if that makes us feel better. Right, but just be aware, you're getting to know me and my style as well. Okay. But I think if you've talked to other people, I like to not throw curveballs. You can do well on my quizzes and my test or my final, anything. Okay. Oh yeah. So back to material. In terms of taking a box plot and thinking about what the distribution looks like, right? Like we did here, where we said, okay, a short distance actually means there's more data in terms of our histogram, right? So if we have a box plot, versus the histogram, right? Here we saw what the box plot looks like for a slightly skewed distribution, right? But if I have a box plot that looks like maybe like this, these are supposed to be roughly equal length, the whiskers, but I ran out of room. In terms of the histogram, what's that gonna look like? Right, so here, it takes me quite a while to cover the first 25% of the data, right? And then relatively quickly, I'm able to cover the next 25% of the data, right? So in terms of our peak in the histogram, right, we're building up a little bit quicker. And then just looking at the median, it looks roughly symmetric, right? And then, so here we cover the next 25% of the data, right? And then it takes us quite a while to cool off and cover the remaining 25% of the data. So in terms of the histogram, it'll be approximately normal, right? Where the median is equal to the mean. So then just to have all the options here, right? If I have something that looks like this, and I'm ignoring outliers, I'm not going to pretend that I have these random outliers, right? But they might be there. But in general, if I have a box plot that looks like this looks similar to what we had up here, right? And so what that translates to in terms of a histogram might be something like this, right? Where the median, remember this central line is the median. So you can use that as your guide. The median versus, and maybe I'll do what we said last day was, okay, the mean is not robust to outliers, so it's pulled in the direction of the tail, right? So only when it's symmetric are they the same, right? Or approximately the same. Same idea, but the other way around. If I have the median up here and maybe a short whisker and then a long whisker, maybe I'll bump that down. All right, might look something like this. The median, and then the mean, again, is being pulled in the tail, in the direction of the tail. And then finally, the one I usually skip, but in this case is worth mentioning. What about this one? This lower whisker is the same length as Q1 to the median and the same length as Q3 to or the median to Q3 and then Q3 to the maximum, right? So they're all the same length. So the only way that we can have that, or one of the only ways, that doesn't make sense, does it? Is if you have a uniform distribution. The median again is equal to the mean because of the symmetry, but you don't want to be talking too much about the mean in this case. I'll say that, but this is a uniform distribution versus the normal distribution, which has these longer whiskers, right? Telling you that things are kind of cooling off in either direction. Awesome. Okay. Get my notes out so that mostly so I don't forget to say anything. Okay. Let's see here. I think we're ready for section 2.2. 2.2 is on summarizing categorical data. So everything that we've done so far in 2.1, right, it took us a whole week to get through summarizing numerical data. There's not nearly as much that we do with categorical data because why? Categorical data is when the information can just be put into groups or categories, right? There's not a ton that we can do there, right? We can talk about how many data points were in each category. That's basically all we can do. And so it doesn't fall all over the place there. Okay, and so categorical data, just as a reminder, is data that can be grouped. That can be grouped. Yeah. And then I'll do a follow-up. It's kind of understood, but into categories. Right. Things like hair color, course letter grade. I'll say etc. because I can't think of any more. There's lots, right? But those types of things, right? Okay. So in each group or category, right, we'll have some count. Right, and that's really all we're interested in terms of categorical data, right? And so that's why there's not a lot for us to do here, right? But each group or category will have a count. Yeah. To summarize these counts, we usually make a table, right? To summarize these counts, we usually make a table. I'm going to make some generic groups A, B, C, right? That can be anything, right? And we do this quite often, right? Is we just create these generic groups to illustrate a concept. And then I do have an example, but it's quite involved. And so we'll start here and work our way out. So here we have group A, B, and C. Just 3 categories, right? And the group is the categorical variable. So let's just remind ourselves here. So the group is the categorical variable with 3 categories. And the categories themselves are A, B, and C. Usually I go for 1, 2, 3, but that gets confusing because it's numerical, right? That doesn't mean it's not done. It is done, but when we're first starting, it can be confusing. So now I'm using A, B, C. So each group is going to have some count. And I'm just going to make up some numbers, 14, 10, and 6. That's a relatively low interest, right? Why? It's hard for us to look at 14 versus 10 versus 6 and gain any information. So what we usually do is we convert these to proportions, right? Because we can talk about proportions and have a better grasp about the proportions. And so here, what I'm adding, I'll put in orange here, is the total, which is 30 in this case. And then here, I'll make a note. We often convert the raw counts to proportions. So here, we'll have the proportions. And I'll extend the table a little bit here. Hmm. 14 out of 30, right? 14 out of the total, right? That gives me the proportion is roughly 0.467. 10 out of 30 is roughly 0.333. And 6 out of 30 is roughly 0.200. Some things to keep in mind, right? If you've converted to a proportion, which is what you're supposed to do, another thing that you need to think about is that these should add to 1, right? 30 out of 30 should be 1, right? So in terms of your rounding, you might need to make some small adjustments, right? To make sure that it adds to 1. 1.000. Okay. Especially when rounding proportions. We may need to adjust the values so that they add to 1. We may need to adjust the values to add to 1. Okay.
Can you convert that in percentage?
Yes, absolutely. But that's my next note. A proportion is just a percentage, right? It's a proportion times 100 is a percentage. And when we're reporting our results, we usually use percentages, right? But in terms of the math that we do in the background, it should be done with proportions, just for kind of cleaner calculations. You can do it with percentages, but I wouldn't recommend it. So a quick note here. In fact, there are 3 P's. Sometimes I hold up 4 when I say 3. 3 P's that are essentially equivalent. Okay, so a proportion is a probability. We're not going to think of it in that term yet, okay, but we will, okay, which is approximately a percentage. Right, so these 3 P's are equivalent. I'll say sort of, for the percentage, right? Because a proportion times 100 is a percentage, but the values themselves are the same, right? So a proportion times 100 is a percentage. Okay, good. So that's just something to keep up our sleeves, right? We're just going to be working with proportions and percentages in this section, but then we'll quickly start talking about probabilities, right? And so that's why it's good to keep in mind that, okay, we've already learned some skills to do with proportions and percentages, and so those translate. Now, to visualize categorical variables, I want you to use bar charts, right? You've probably seen some other ones, right? A pie chart is super popular, but it shouldn't be. I go on a small rant about how much I hate pie charts in just a moment. But in general, right, we should just be using bar charts. They're boring. There's like donut charts, and I'm sure Excel has all these fun, exciting charts that you could use. But for us to visualize categorical data, we should use bar charts. Or bar graphs. It's one of those, it's 2 or 1 word. You can use charts, you can use graphs, doesn't really matter, right? We just use them interchangeably, whatever sounds good. And so just, I'm gonna make a note about the pie charts, but there's been a lot of research done that our brains are not good at looking at an object like a pie chart and immediately knowing which one is the biggest one, which one's the next biggest one, and immediately classifying the categories, right, from smallest to largest, for example. And so our brains just are not good at that, okay? And so you can add things. You can add things like the counts or the percentages, right? But one thing to always remember is when you're visualizing things, the main goal is to have it be as simple as possible and still communicate information. Okay? So that's one of the core ideas of data visualization is it should be as simple as possible, but communicate as much information as you can. Okay. So when you start adding labels and things like that, and if you have to have a lengthy legend, then it defeats the purpose of data visualization. Okay. So in general, let's see here. One thing to always keep in mind when visualizing data is to keep it as simple as possible. Is to keep it as simple as possible while also communicating as much as you can, right? While also communicating as much as you can. Someone should be able to look at your data visualization and say, oh, okay, I understand, maybe with just a header and depending on what graph you're doing, right? There might be some axes or something, right? Depends on, you know, how much you want to communicate, right? But in general, as simple as you can, that's always the best data visualization. And I've gone down that rabbit hole, right? Where I make this crazy graph and I think, oh, I've captured so much information here, right? Wow, so many variables are taken into account here. And, but then when you take a step back, it's really hard to explain, thus defeating the purpose, right? And so you don't want to get caught in that loop, but it happens to everyone. Okay. So one thing about pie charts. So pie charts, right, are used for categorical data. They are, because each slice of pie is a category, right? And so you can use them. So pie charts can also be used to visualize categorical data. But it is often difficult to distinguish between the sizes of the slices. It is often difficult to distinguish between the sizes of the slices. Slices. Yeah. I've got, where is it? Oh boy. Maybe it's here. Ooh, beautiful. I skipped those geographic ones. Oh, haha, here it is. Okay, so even the textbook makes fun of pie charts. The only pie chart you will see in this book, right? This one is not as extreme, so it doesn't really matter what the data is about. In this case, we're just looking at the different slices. In this case, it is relatively easy to see the differences, right? But then I have, now I'm going to try to find it. I said I wasn't going to, and then I did. Wanted to anyways. It's probably at the end. Oh, there it is. Something like this. Right, versus something like this, where you've got a pretty good idea, right? We can look at this, but we'd have to spend a little bit of time trying to figure out, okay, which one is bigger between 4 and 8, for example, right? And so it's not obvious anymore, even with the same style of labels and the same different coloring and whatever, right? In this first one, it's relatively obvious, but that's not always the case, right? Here, it's hard to tell what the slices are, right? Which one's the biggest, which one's the smallest, right? And so versus, where was it? Wait, that's not it. This one. Versus the bar graph. Now, we haven't talked about a bar graph yet, but here it is. It's exactly like it sounds. It's a bar. That's the height of how many things are inside each category, right? And so we can have the raw counts, right? In this case, it's the frequency, how many people rent, how many people have a mortgage, how many people own, I guess, have paid off their mortgage would be the difference probably. Right? So here we have the raw counts, but you could just as well have the frequency, or sorry, the proportions. What would that do? It would just take everything and pull the scale down between 0 and 1, right? But though the graph itself would stay the same, right? Same thing, and this is the one where it becomes more obvious. Is when we compare this pie chart, right? But now when I have these bars here, right? Our eyes just immediately can tell which one's the biggest one, which one's the smallest one, the middle one, right? And so that's important. And yeah.
It's also difficult to find the distribution.
So although we do talk about that sometimes, because we have categories here on the x-axis, it's going to look like a histogram, but we don't necessarily talk about that. We could talk about it if it's ordered like it is here, right? But if there's no real ordering, then it's not something that we would talk about, right? So when we talk about distributions, I'm going to say, just for simplicity's sake, let's reserve that for numerical data, right? For categorical data, we can just talk about, which one's the highest, which one's the lowest, that kind of thing. Right. And so here, let's see here. Right here, it's easy to see which category is the largest, smallest, etc. And so that's the take-home message. And like I said, there's been lots and lots of studies on how our brains perceive things. Our brains are not good at seeing. I think, is it this kind of spatial relation? I think it is. Anyways, it doesn't matter. We're not good at it. Our brains, it's not us, it's our brains. Operator error. Okay. So, like I said, in the bar chart, we can clearly see the different counts. And I'm going to say add the proportions, right? Because it could just as well be the proportions on the y-axis, right? Instead of the frequency. So in the bar chart, we can clearly see the different counts. In the categories. Or maybe I'll say accounts / proportions. Could be proportions. The funny thing is, the only time a pie chart is obvious is if you only have 2 categories, right? But let's take a step back and say, okay, if I've got, so here, the only time a pie chart is obvious, right, in terms of reading it and understanding the sizes, right, is when there are only 2 groups or only 2 categories, right? So for example, a quick example here, that's my sloppy pie here. And what if I have something like this? Right. Let's assume that I have 25% and then 75%, right? It was supposed to be a quarter, right? And so here, right, should you be doing this? Or could you just say, so here, let's say yes and no. Couldn't you just say 75% say yes? Right? You could communicate everything that you needed with just that one line instead of a graph, right? And so maybe I'll say instead, we could say something like 75% say yes, right? If I tell you the probability of getting an A in this course is, no, I'm making it up, 60%. What? That means 40% chance I won't, right? Your brain already does that, right? And so your brain already creates the second category. And so this is kind of the take-home message. So in terms of, usually we're building kind of dashboards, right? Clients still love dashboards, right? Just you go in and you look and all the information that you want there is there, right? And so here you would just have this kind of changing number, 75% say yes or whatever, right? And so you can communicate it with just one number. We can communicate all the information with just one number. Right. And so this is where I'll see if I can play it here, just in case you haven't watched. Oh, of course they are. Okay. Anything I can do about it? Not really. Just try again, I guess. So this is why I had to film this one.
Be surrounded by killers?
You don't think people in this store do
it's playing.
marijuana, do you?
I mean,
Probably.
How many of them?
Like half.
Half. Wait, half do or half don't?
It's both.
okay.
Anyways, so that was me standing in front of my TV filming it because I thought it was so funny. But it's from Superstore, yeah. Yeah, pretty funny. So that's on our Moodle page in case you want to go back to it, right? But that's exactly what would the pie chart look like, right? 50-50, half do or half don't. It's both. It's both, right? And so you can communicate everything with just one number. So anyways, I thought it was a cute example. But it takes me a while to get to this section, right, where I introduce that video. I should reorganize everything so I can start with that video. Fun way to start. Okay, so in terms of one variable, right, we saw that, okay, to summarize it, really all we're doing is we list the groups and then we have the counts or the proportion, probably rather. And so we can do the same thing for two categorical variables, right? Usually I'm not just interested in one, I want to look at two categorical variables. And so that's when we make a cross tab or cross tabulation, I guess. So to analyze the relationship between two categorical variables, we can use a contingency table. Use a contingency table. A cross tab, if you're familiar with that wording instead, that's totally fine, but it is called a contingency table. And so we might have some variable number 1. Let's keep the ABC. Right. So here I have the categories of variable 1. And then up here, right, I'm going to have the categories of variable 2. Now, what am I going to call these? Maybe I'll do red, blue, and green. Something. It's mostly fluky that they each have 3 categories, right? They can have any number of categories, more than 1, obviously. But so here we have the categories of variable number 2. I'm not referring to anything, so if you're looking back, right, that might be confusing, but I'm just making these up. Okay. In terms of the anatomy of the table, okay, we're often, if they don't exist already, we're often going to add the totals, right? Both the row totals as well as the column totals. Okay. And so here, it's going to look like this. Total like that. Okay. So these are the row totals. Okay. So here, this would be total in group A, right? This would be the total in group B, and this is the total in group C. Now this, right, if we're talking about the raw counts, which is easier to think about right now, and we can convert them to proportions if we want to, but let's talk about or think about raw counts, right? These should be the same as what we had previously, right? Assuming I'm talking about the same made up variable, right? 14, 10, and 6. Right, but those counts are going to be spread across these groups here. And then so down here, you're going to have the total in the red column, the total in the blue column, and the total in the green. And these are the column totals. Oh my gosh. Can't write column for the life of me. There. And then finally, you're going to have the overall total, which is your overall sample size N, right, in that lower right-hand column. Okay. I'll say it, but I don't want to write it down because it becomes a lot of terminology. But these totals, these column totals and the row totals are called marginal totals because they're in the margins. Okay. But I'm going to bring that up again when it becomes more important. So that's just the name of it. We'll call them row totals and column totals for now. Okie dokie, artichoke. I've got an example that I need to steal from where? When do we think it might have been? Nope. Okay, that's the 27th. Okay. How can I have it? So this is stolen from an assignment that I can't access right now. So you can just be happy, don't have to do it. Guess. Wait. Okay, and I want to erase all this. Yeah. What I should have done is had this, but what I want to do is just have a moment here where we can read through this, and then I've got some questions for us to work through. Okay. So 1240, so 1,240 randomly sampled registered voters from Tampa, Florida were asked if they thought workers who have illegally entered the US should be 1, allowed to keep their jobs and apply for US citizenship, 2, allowed to keep their jobs as temporary guest workers, but not allowed to apply for US citizenship, and 3, lose their jobs and have to leave the country. And then they also asked these participants what their political ideology is, right? How they vote, okay? And so we have 2 variables, right? And those 2 variables are categorical variables, right? And so here we have kind of variable number 1 with 4 categories, right? And so I'm just going to call this, I want to have a name for this variable that I can refer to, right? And so just in general, I'm going to call this citizenship, right? These are basically citizenship options, right? Which one do you choose? 1, 2, 3, or 4? And so here I'm going to call this the citizenship variable, which has 4 categories, right? Because it's a categorical variable. And then the second variable that we're looking at is how they vote, right? Conservative, moderate, or liberal. Okay. And so here, let's just call this the voting variable, which has 3 categories. Okay. So we're just getting used to looking at something like this. And so we see that there are the totals here. So we've got these row totals, the column totals, right? And then finally the grand total here, 1,240. So here, right? N is 1,240. Okay. So if I asked you to answer something like, okay, how many of those surveyed were in favor of the guest worker option? So here, the guest worker option I'm not talking about how they vote or anything, right? And so it'd be 134 plus 146 plus 32, which is 312 out of 1,240. Yeah. So even though these questions can get a little bit difficult in terms of the wording, right? You can grab all the information that you'll need from this table. Okay, so let me go and try to remember where oh, you know what? I have them here, so I'm just gonna write them out. So part A that we want to answer is, what percent of these voters identify themselves as conservatives? What percent of these, and I'll specify Tampa, Florida voters, just because I have it here, voters identify, I'll say, as conservatives. So now we're not interested in anything about how they feel about the citizenship options, right? We're just talking about the conservatives, which is going to be the 490, and we want that as a percentage, right? So then 490 divided by 1240, right? And so far so good, feeling good. Okay, so here, that's going to be the total conservatives divided by the total voters, which is 490 over 1240. Nice. I've got it here, it might be wrong. 0.395161293. As a percentage, 39.52%. Oh, and it did say round all answers to the nearest hundredth is what? 2 decimal places. Because 10th is 1 decimal place, 100th is 2 decimal places, 1,000th, 3 decimal places, etc. Okay, so then that's our answer. 39.52% of these Tampa, Florida voters were conservative, or said they were conservative. Usually if someone asks me, I just tell them whatever they want to hear, so I don't have to talk to them anymore. That's bad, Emily. Oh yeah, for sure. You got my vote. No. Okay. What percent of these, why am I being so sticky about defining of what group? So of these Tampa, Florida voters, right? Because our information was drawn from randomly sampled registered voters of Tampa, Florida, right? So that's the group that we can generalize to, right? That's where we took our sample from, right? That's the population. And then we have a random sample of those guys, right? And so our results can only translate back to registered voters from Tampa, Florida, right? So very specific. So that's why I'm being extra sticky here. So what percent of these Tampa, Florida voters are in favor of the citizenship option? Now I think we need Table again. So again, we're not talking about how they vote or anything like that. It's just who's in favor of this apply for citizenship option. And that's going to be the total is 393 over 1240, right? Nice. Let's see here. So that's going to be the total citizenship divided by the total voters. 393 over 1240. 0.3169354839. Keeps going, but that's all I can see. And it asks for the percentage. Right here, it could say what proportion, and then we would be done. Right, to 2 decimal places, gets weird. 31.69%. Okay. I'll start C on the next page here. What percent, so again, of these Tampa, Florida voters, what percent of these Tampa, Florida voters? Whenever I say Tampa, for some reason I turn American. Tampa. I don't know why. Maybe that's all I've ever heard. I've never heard anyone say Tampa normally. What percent of these Tampa, Florida voters identify themselves as conservative? Hey, we've already done that one. And are in favor of the citizenship option. So we want them to be conservative and in favor of the citizenship option. Okay. Now we're getting somewhere, right? So they have to be conservative. So we're limited to this column here. But then we also want them to be in favor of the citizenship option, option number 1, right? So the total there is 59. Okay, and we just want to know how many of all these voters, right, fit into this category, which would be 59 out of 1240, right? And so it's going to be, they have to be conservative and in favor of the citizenship option. Highlight that. Divided by the total voters. 59 over 1240. Oh, this is a 9. Nice. 0.475806451 4.76%. Right, rounding to 2 decimal places properly. But you guys go. You're doing it. Okay. Ready for a doozy? Okay. This part stays the same, so I'm gonna just cheat a little bit. What percent of these Tampa, Florida voters who identify themselves as conservatives are also in favor of the citizenship option. Feels a lot like the same question, yeah? Okay, but now we're saying, okay, what percent of these voters who are conservatives, right? So now we're limited to just out of the conservatives, then what percentage are in favor of the citizenship option? Right, so these questions, right, as if you have the table, which you will, are not hard, right? It's reading the little question and figuring out which numbers to pull from, right? And so here, right, the key part is this one. This changes the total, right? Because now if I just jot it down here, they have to be conservative and in favor of citizenship over the total conservatives. Okay, so that's the difference. Now, if we go to the table, which is quite far away now, right? So out of these 490, right, 59 of them were in favor of the citizenship option. So now we're doing 59 over 490. Nice. 59, 490, 0.120408163. 12.04%. What percent of moderates share this view? Right, in favor, just to clarify, in favor of the citizenship option. Same idea, right? But now we're talking about the moderates instead of the conservatives, even though it's from the states, most likely, so not sure where this falls, but right. Two-party system. So they have to be moderate, but 151 out of 492, right, are in favor of the citizenship option. So 151. Oh, I guess I should write it down first. So now they have to be moderate and in favor of the citizenship option over the total moderates. $151 over 492. Just to keep it on the same page, I'm going to go across the page here. It hurts a little bit. 0.3069105691. 30.69%. Then I'm out of time, but we're going to do the same thing for the Liberals. And what are we going to look at? We're going to compare, okay, these percentages are changing depending on how they vote, right? That's what we expect, right? But then what does that mean, right? So anyways, we'll pick that up on Thursday. If you have any questions, let me know. Otherwise, I'll see you then. And I'll bring a practice quiz. Do you guys want them printed out or printed? I'll try. I just realized I don't have access to the printer. I'll try my best.